Thank you very much. Actually, I changed my title. I have a bit of a conflict here with some of the people in the room. So algal biofuels have been a thought for many years, actually, since the Second World War, in fact. The Germans tried very hard to displace their dependence on fossil fuels in the Second World War by using coal and developing alternative energy sources with algal biofuels. That continued on in the 1950s in many places in the world, including the United States. But obviously, it has never penetrated into the market. So how do I change this here? How do I make, oh, okay, so what I'm going to talk about is a little bit encompassed in a book that I wrote and it's been published last year. It's put out by Princeton University Press, and it's called Life's Engines. And most of my life has been studying the process of photosynthesis. So I want to put this out to you in a very, very large way. So I'm head of the Energy Institute here at Rutgers. And I think about energy in a strategic sense. And let's just think about this in the following way. There's an energy identity relationship which is rather simple. It's based on the product of three terms: the number of people on the planet, the GDP per person, and the energy per GDP. And if you just go through that, you see that you just wind up with energy on one side and energy on the other side. So it's an identity. Rather simple equation. Now, the GDP per N is something that economists like to see go up. The N is something that is going up. And the E per GDP is something you want to see stay constant. So now you're fixed with two terms that are going to go up. Not good. All right, now, in 2005, when I was serving still on the editorial board of Science magazine, Joel Cohen at Rockefeller University put out a paper in a special issue on what was the population of the planet going to be. And the demographers at that time calculated that by the year 2050 we would tap out at about 9.5 billion. Wrong. Wrong. Why is it wrong? It's wrong because we didn't get the second decimal place of childbearing, of children, of number of children of women in childbearing age. The second decimal place. It was off by 1 unit. 1. So now the number is uncertain within a half a billion people of between 10 and 10.5. Let's continue on. In terms of energy, in 2015, the total power generated by the entire world was about 16 terawatts. That's 16 trillion watts. About 1.4 billion people on the planet don't have a wire in their house. They have no electricity at all. None. Zero. So we have 7.2 billion people on the planet, about 1.4 billion people that have no power. Zero. If we go to 10.5 billion, and we want to keep a GDP per N at a reasonable number, we're going to have to generate approximately 30 to 32 terawatts. We're going to have to double the power supply. That's a big lift. If you want to do that in a carbon neutral way without nuclear energy, God help you. So let's just take a look at this today. The Paris Accords, which everybody is very, very pleased with. Let's just imagine that we had 100% carbon reduction. We're carbon neutral as of now. We just had no emission of carbon from any source of power. We would have saved only 50% if we have to generate another 15 terawatts, okay? So you cannot conserve your way out of this. You have to transform the way we make energy. Now, in 1859, in the northwest corner of the state of Pennsylvania, right next door here, in this little town of Titusville, there was an itinerant train conductor named Edwin Drake. And he drilled the first lined oil well. We knew what oil was. Petroleum has been known for thousands of years from seeps. Petroleum literally means rock oil, right? Petro is rock, oleum, oil. So he drills a little well. After about the 15th attempt, this was called Drake's Folly, he actually gets oil. What do you do in 1859 with oil? 1859, you got to remember, 1859 is when The Origin of Species, the first edition, is first published. It's when Big Ben strikes for the first time in London, showing the power of the Industrial Revolution in England. It's when Abraham Lincoln is elected president to take power in 1860. There isn't a car. There's no such thing as an internal combustion engine yet. The petroleum was distilled to make kerosene. And Drake saved whales from extinction. We were burning blubber. That's what whales were harvested for. They were just being demolished. By the way, in the 20th century, after we found a way to make an alternative for blubber, we still killed 100 million whales in the last century, okay? So just to show you how crazy humans are. But to go on with this a little bit, Drake went broke, Standard Oil and Rockefeller became the largest corporation on the planet, and they owned oil all over the world except in Indonesia, where Royal Dutch Shell made a major strike. The following occurred. From 1859 to present, we harvested oil, coal, and natural gas and used those fuels, which are basically fossil stored solar energy fuels, to create a power supply for the planet. And we still do today. So only 18% of the electricity in the United States is based on nuclear power today. 18%. 1% is based on renewable from direct solar power. So that means 80% approximately, a little more than 80%, is actually based on still the combustion of fossil fuels. So we have many, many, many things that we can do. As Chuck Dismukes emailed me last night, we actually crossed a threshold yesterday where right now the concentration of CO2 in the atmosphere is 400 parts per million. The beginning of the Industrial Revolution, when Washington crossed the Delaware, when Hannibal crossed the Alps, it was 280 parts per million. So you went from 280 to 400. That it's due to fossil fuel emissions is no longer even debated. It's absolutely not because of natural causes. Now, what does this mean? It means that in 1 year, we can extract 1 million years worth of fossil stored energy from the ground. So we're very, very smart animals. We can extract something that has been, takes nature 1 million years to put there, we can take it out in 1 year. Now, the fuel consumption is not going down. And the reason is because the GDP of developing countries is going up. And that's a good thing for human economies, but not a good thing for the planet. So the fuel use increase, which is the lower right-hand corner here, is highest in the developing countries. You see, the United States, actually, the fuel use increase is going down. But if you take a look at China, Korea, India, it's going up. 20 years ago, when I went to China for the first time, bicycles were all over the street in Beijing. No more. Cars. Shanghai, cars. India, cars. Japan, cars. Korea, cars. And electricity is everywhere. And China, almost all the electricity is based on coal. Now, we're not going to run out of those fossil fuels anytime soon. There's about 8 times the amount of CO2 in the atmosphere is still in the ground in known fuel reserves. And if you want to find that number very precisely, I urge you to go to the CIA website. The CIA keeps a very, very good website on the known reserves of oil, coal, and natural gas in the world. A lot of this is confidential information that oil companies don't want to give out, but the CIA obtains it. Okay? That's what they're good at. So they're good for something. And I'm telling you, your children's children's lifetimes, there still will be ample fossil fuel in the ground. We're not going to run out of it anytime soon. So it's not a supply problem. The idea that we've hit peak oil or peak gas or peak coal is nonsense. It's just nonsense. And it's really funny because today, oil is so abundant in the United States because of fracking and horizontal drilling. One guy, George Mitchell, figured out how to do this. His son is a colleague of mine at Scripps Institute of Oceanography. He's a phytoplankton ecologist. The other 5 children are ultra conservatives. Just saying. When Mitchell died, he left an endowment of $12 billion in a foundation. Virtually all of it goes to Texas A&M. Now, so I've just said that. So here's the question for the bioeconomy. Can we replace the bonds that we are using from stored fossil fuels in real time using present solar fluxes? In principle, yes. But I'm going to very, very quickly, why would we do that? So here's where we're stuck in the United States. We gave this problem to the Department of Energy. It became an orphan. It didn't go to the Office of Science. It went to EERE, Energy Efficiency, which is not a research arm of the Department of Energy. It's an orphan in the Department of Agriculture. It's orphaned in virtually every federal agency in the United States. Why? Because we have so many people that doubt climate change is real. It's a hoax. One political party in this country thinks it's absolutely a hoax. One political party has huge power in this country right now. The secretaries of energy, Chu, right? I mean, I've lived through many secretaries of energy in my life. I worked at Brookhaven National Lab. I know the secretaries of energy for many years. Not one of them, not one single one of them believed in algal biofuels. Not one. To this day, Ernie Moniz does not believe algal biofuels are a solution for anything. We have invested $500 million in ethanol and cellulosic ethanol. We've invested less than $200 million, less than $200 million. This is nuts in algal biofuels. Meanwhile, we're looking at sea level rise that will probably be on the order, conservatively, of 1 meter by the end of the century. Global mean temperatures are going up. So what I worry about really is these climate tipping points. Ice sheet disintegration, species extermination, methane hydrates exploding, massive changes. So theory, algal biofuels can easily displace cellulosic ethanol or any other fuel. The economics is what the problem is. It's not a problem of biology. We know how to do this. No algal biofuel company can be anywhere near making any profit when you have oil that is so abundant and selling at $50 a barrel. The cheapest algal biodiesel that any company can make now is $200 a barrel. So the idea of DOE of doing everything at once was absolutely insane. They should have focused on the biology initially in Office of Science, and they should have focused on engineering. This is something that the DOE knows how to do. I'm not talking about biological engineering. I'm talking about physical engineering. The physical engineering problem has been just left aside. Now, ultimately, the light problem is the simplest one. We know basically this equation, and you're paying for real estate. So the physical engineering problem is the one of paying for the real estate. So we can monkey with our genes, which we've been doing for many years. And I'm not going to go into this because everybody in the room basically knows we can do this. We can CRISPR our way out of anything almost. I'm trying to, won't move. Ah. Cool. All right. Now, hold on. So the engineering effort really is where I would put my money. No algal biofuel company knows how to do this. None. They've invested huge, huge amounts of money privately in engineering genes and not understanding how to actually grow the damn things in the real world at scale. And that's where we need investments, not of hundreds of millions, but of billions of dollars. Billions of dollars. Now, there's one other concept I want to touch on very briefly. It's the idea that in order to make this economic, you have to have a secondary product that's of high value, which is totally stupid. Because if you're going to make a commodity, like a biodiesel, you're going to drive the price of the secondary product down to zero. So the secondary product can't save you. Now I'm going to finish up with this. This is what stops us in the United States. It's the Kaya curve, which every economist knows, named after the Japanese economist. And see that GDP per capita, which was in my energy identity equation? And you can see the energy consumption in kilograms of oil equivalents per person per year on the bottom. And this is a log-log scale. So you can see the United States is not the worst actor in the planet. It's Qatar. But if you really want to shift the world, you'd go from the US to the UK, which has very similar GDP, but 1/2 of the carbon consumption per capita. This curve has stopped every major change in the use of fossil fuels to a bioeconomy in the United States. That curve. So that curve has dominated everything over the last 30 years. Everything. So we basically are fueling up our cars with ethanol derived from corn, which is one of the stupidest uses of corn that you could possibly imagine. We have no bioeconomy based on algal biofuels. We have very, very little hope for cellulosic biofuels in the near future. And I'm afraid that these curves really are indicative of a fossil fuel-driven economy. That's what they are, right? So they're fossil fuel-driven. You have high GDP, because of fuels that are based on stored energy in the ground. And now you say, well, I can't get around it. Well, that's a tautology. You've just given yourself a tautology. A is equal to A. So I'm going to stop here. I've gone on, I think, a little bit too far, but there is only one way. There is only one way to get out of this conundrum, and that is a tax on carbon. It is the only way. Okay? Without an economic solution of taxing carbon, we will never get out of this problem. We'll just always have available, cheap fuels that are in the ground, and companies will extract them. Thank you.